Okay, hello everyone. I'm Robert, this is Karsten. And yeah, today we want to talk about hacking space. And yeah, so that our agenda, I don't know if you can call it an agenda or table of contents, so to say, I want to talk about three things. So actually, who's PTS? PTS stands for part-time scientists. That would be us, our team. What happened so far? So what have we done? Not just what have we done at all, but what have we done especially in the last 4 years and in the last year? That's something that we want to do very briefly, the introduction and what happened. And then, that's the most important thing for today, how you can be a space hacker. Okay, so let's have a look at the part-time scientist. So we're the part-time scientists, are a team of scientists and engineers building space hardware. So what does this mean? This means that we take everyday hardware and technology, so that's stuff that maybe you can even buy at your local electronics store, and some stuff that you probably will never buy at your local electronics store, like FPGAs, but that are still out there and that you can still get your hands on. And we try to modify them and get them workable or get them working in space environments. So why are we doing this? Our goal is to lower the entry barrier to space with technology. This means that in space exploration, you have to deal with a whole lot of extremes. You have environmental issues, you have temperature shifts, especially on the moon, of over 250 degrees in Celsius. You have radiation environments, which is over 100 times the amount of radiation that you have here on Earth. And you have a whole lot of other issues, I don't know, like crashing into planets and stuff. So you need to build hardware which can withstand this environment, and we can actually do something. Also, you have some limitations in regard of resources. And we think that if you have the right kind of technology, which can do the job better than existing technology, then you can make things easier. You can actually get some advancements in space which are just solely due to the technology. And yeah, also, just in the meantime, by the end of next year, we hope that we've developed everything to personally send a rover to the moon. That's our goal. And that's what we try to do as the part-time scientists taking part in the Google Lunar X Prize competition. So yeah, that's our goal, and that's what we're doing. So what do you need to privately get to the moon? So you need, for example, a service module. That's something that we've designed. And you need a landing module. The service module is what you can see on the left side. That's basically the thing. It's like the upper stage of a rocket, which gets you all the way from the right Earth orbit to the moon orbit. And then you have the landing module, which basically, as the name suggests itself, is this module which gets you down to the lunar surface safely. So that's actually the unit which has the right kind of thrusters to lower you to the surface and then gets dropped and touches down. And totally, of course, for the fun part, we have a lunar rover with us that we want to take to the moon, and that's the Asimov rover. That's actually an image which shows you the rover as we thought it would look like about a little bit like 40 months ago. And then we have to look inside the presentation to see how it looks like today. So, and of course, the rover has its purpose. It has all kind of scientific and non-scientific equipment. It has like pretty cool HD cameras that we think are important to get onto the moon, and it has payload capacities, something that we will talk about later. So what else do you need to do something in space? You need rockets. And in this case, you need a really big one, because if you want to go to the moon, you need a rocket like this one. So this thing looks huge, and it definitely is huge if you stand right in front of it. However, compared to the everyday rocket that you probably heard of from the media, like the ones that SpaceX is building, you know, the company with Elon Musk and Tesla, that's actually a smaller one, because what we need to get our mission to space is like 3.75 tons of mass. So the SpaceX, the Falcon rockets, are actually 10 tons and more. So they are in the category of so-called heavy launches, and what we are aiming for is the category of satellite launch vehicles. The great thing about satellite launch vehicles is that they're really cheaply available. So because there are like, I don't know, hundreds of satellites being launched all the time, and this makes it a mass market. However, it is a challenge for us to get everything that we've built to make a mission towards the moon with only this kind of mass that you have available. Because you really need to fit everything that you need, your fuel, your structure, and everything you have in this little amount of mass. So that means that we have to really integrate and, I don't know, build stuff smaller and more lightweight than you would do with a larger rocket. Okay, so that's so much for PTS. So the question is, PTS in 2014, or what happened so far? Let's make a small step back. 5 years ago, as of today, we actually kicked off our team and our idea right here at the CCC Congress. So it's 5 years now later. And back then, we presented to you an idea. We actually talked about, I can't imagine today, but if we talked about 3 hours long about concepts and idea of privately getting to space. So, and we actually, in the past 4 years, we actually tried everything we can to make these ideas come alive. And something that we're really proud of is that at the end of 2013, we were selected to be one of the teams being awarded as one of the $6 million grand prizes of the Google Lunar X Prize Milestone Prizes. Because a panel of independent judges that was set up by Google, which consisted of members from NASA and ESA, they've looked at all the technology that we've built in the past years, and they said, hey guys, this definitely is not space hardware. It's not like we would have built it, but we believe it can work in space. It can get the job done. And this was a pretty awesome thing for us. And this led...
Maybe you should explain what the job actually is. So,
okay.
Okay, so the goal of the Google Lunar X Prize is that you send something, probably a rover, to the moon, and you drive around at least 500 meters, and you transmit back HD video while doing so. And when you have done this, and then you will get like 20 million bucks, or is it more? No, 25.
20 million.
20 million bucks. And there are also some additional prizes, so that if you're able to drive like 5 kilometers, then you get some more money, and some, if you detect water, you get some money, and if you drive to a heritage site, like the Apollo site, you will get some money. And yeah, in the end, you can get up to 30 million US dollars, which sounds like a lot. But unfortunately, the rocket that we showed to you, which is like one of the cheapest, it's the cheapest.
It's the cheapest option available.
Yeah, it's the cheapest from the Russians. So this one is like already around about 20 million US dollars, or even a bit more. So you see, there is no, we will not be very rich once we have sent the rover to the moon. The mission overall will be much more expensive than that. But what the X Prize Foundation, which is running the Google Lunar X Prize, wanted to have is to show that the teams are capable of actually fulfilling the Google Lunar X Prize in itself. And so they set out the milestone prizes, which is a competition within the Google Lunar X Prize, where you have to show that the hardware that you build should be able to drive on the moon. But don't forget that we will actually have to land on the moon itself before we get the money from the Google Lunar X Prize. So it's not like there is a competition where at the end Google is shooting up the rocket, and then you will get the money, and all the rest is done in CGI.
Yeah, and I think that's the main misunderstanding about the Google X Prize, that it's not about the money from Google. It's more like as it's called, an incentive. So it incentivizes you to figure out ideas to actually get your technology to the moon, and that is what we've been trying to do the past 4 years. So we've compiled a short video, and we were debating if it's maybe too long. It's a 3-minute video, but I think your attention span can deal with it. Okay, so everything that you saw, the test of the past year, something that I would have personally never believed about 40 months ago when we were selected for these additional prizes, that we can do all this test and would actually pass all of them. That's something that I would have never believed. I don't know, build something on your own and put it on a vibration table and be sure about that it works afterwards. That's definitely not the feeling that you will have. And that is something, because just I want to highlight this thing, because for me, because he managed to pass all the qualification tests that we've put him through, Asimov, our rover, is my hero of 2014. And just to highlight just very few things that I think are totally awesome about the technology that we found and worked with in the past is one thing in this case, for example, is 3D printed metal parts. I don't know who of you, all of you know 3D printing, but one thing new thing that we've explored on our end was 3D printing, in this case, aluminum and titanium parts. So we've worked with a company like SLM Solutions, who helped us, for example, to make our wheels and the camera head unit, the camera focus unit, solely 3D printed part, which gives us a whole lot of advantages. Something that, for example, I had to understand. A good thing is that you can do the cable routings inside the parts itself. So it's actually much easier to put the cablings in there, which is something that, I don't know, if you want to do it on a CNC part, then you have like 10 parts in the end, and so you get just one part out of it. So that's something pretty awesome. And another thing that we were pretty happy about this year was the dampening elements of our landing module. So, because of course you have this landing module which turns off its engines above, I think, 3 meters? Is it like?
Yeah, something like
that. 3 meters above the ground. Then it touches down, which always sounds so softly, but I don't think falling 3 meters is soft. So it has this dampening elements to take off all the load. And that's something that we've worked out with this carbon fiber structures together with the guys from the TU Vienna space team, which are also building awesome rockets, and they're really cool guys. And yeah, so that's just one of the few key things that we had in our developments, which I think are cool. And now, I want to get over to the subject where you get involved. Karsten?
Well, I think you forgot something.
Okay.
I want to emphasize this little guy, which is our camera. And you might be wondering, why does it have like 3 lenses? So we have 2 wide-angle lenses on the outside, and we have 1 tele-lens on the inside, on the middle. And something that's a bit special about the middle one is that it's a black and white sensor. And what you saw in the video was the filter wheel that we're using to capture different wavelengths. And so this is part of a scientific payload that we are sending to the moon. That we have a camera that can capture different wavelengths to do analysis of the stones, of the material that is composited on the surface of the moon. And the outer ones are just regular Bayer pattern color cameras, which we use for driving and recreating a 3D scenery while driving around, which is helpful for navigation. Also, we put some of the electronics in an X-ray because it looks awesome. But one of the things that we noticed when we were developing the idea on how to send our rovers to the moon is that we had to fix the solar panel somehow because it can be tilted. And one of the problems when you are sitting on a former intercontinental missile is that the launch is quite heavy, that you have bad vibrations. Not the musical ones, but you have vibrations. And so those get very high, and so we need to fix the solar panel. And so we put in little triangles in here. And those little triangles are very interesting because we call them drop container, because they are, during the flight, they are in there to stabilize the solar panel. But when the rover drops from the lander, which is like this height, it drops on the surface, then they are still in there, and so we can drive them around, and eventually we can drop them anywhere on the surface. And so we decided that this is not just a triangle, but it's scientific payload. And so we have 2 rovers that are attached to the bottom of the landing module, and they drop on the surface and they can drive, and they each have 2 drop containers, and they can be placed anywhere on the surface of the moon, which is pretty cool. So we can bring a total of 20 kilograms on the surface which is not directly attached to the landing module, but somewhere out there. And what this is about is that we are making the specification open so that you can actually suggest a payload for us that we are bringing to the surface of the moon. So the specification is that this triangle almost fits a CubeSat. So the idea is that if you have any hardware that has already been proven in some CubeSat technology, you can just use it. And the idea is that the container sits on the rover, falls down, and then unfolds so that it sits flat on the surface. And on the side that unfolded, you have solar panel which give you the energy. And we will provide you with some UART that you can use to communicate with Earth in the end.
Can I do this one? Okay.
Okay.
When we thought what's inside our drop containers, so of course we wanted to use, we have some ideas. We have, actually I have like 1,000 ideas of stuff that I would like to shoot to the moon and just try it out also. So, and so that we actually had some good use already for our drop containers. So, but the point is that we thought it would be a really nice idea to offer some space to you as well. However, let's have a quick look at what else is part of our on-surface payload, that stuff that we as PTS want to bring there. The very first thing is a Lunar Regolith Rapid Prototyping Demonstration Unit, or simply a 3D printer. So what we are doing and where we build prototypes of is a 3D printing unit which is capable of collecting lunar soil, refining it, and printing small parts out of it, solely out of the soil, without any binding material. That's a very important thing, because most 3D printers work with binding material. Here's the goal, to actually only use energy and lunar soil. So, and this is just a demonstration, so doing something simple like, like a flat gear in this case. But the point is, think about the implications if a demonstration unit like this works on the moon. For me, this really changes everything in regards to space exploration, because the biggest challenge is actually to get stuff somewhere in space or on the moon. And if you can just build it there, or large parts of it, that's a huge thing. So that's a very important thing as a payload for me. Another thing which I really love, I don't know, due to my technical background on information storage, is the long-time data archive and future non-mankind retrieval stuff, which basically means that we want to take 3 of these, which is a standard industrial M disk, which is a technology originally developed by NASA for one of the Mars missions. And it's a special kind of DVD. Actually, it's like a DVD that you can burn, that you can actually buy it for yourself. It's really expensive. But if you need to store something for 1,000 years or more, then it's your DVD. The point is, what would we do with this? Normally, I was thinking about, hey, cool, we take one of these DVDs, or we take like 3 DVDs, burn the entire Wikipedia with Wikimedia, everything from state of the moment of the launch, onto it and bring it to the moon. How awesome is this? All the knowledge of mankind preserved on the moon. Now, thinking one step further, I was thinking about, do you think, which one of you in the audience thinks that we can read DVDs in 30 years from now? If there's somebody there who says, yeah, I can do it, then I give you 50 years. And then I give you the question, think about somebody totally different, who's maybe not from Earth. I don't know, maybe he's from Earth and doesn't know anything about us, or maybe he's from somewhere else. And he's walking up to the rover and he's seeing this stuff and he's thinking like, is this art or is this trash? I don't know, what is this, you know? And that brings me up to the question, and that's something that we will also put a proposal out there, because we haven't found a solution yet, is how to make sure that somebody can actually read the data stored on this. And to give you an idea of what we are thinking about, we want to bring 3 M-disks with us, Blu-ray, DVD M-disks with us to the moon, and 3 metal plates. These metal plates are just very thin, and there will be laser-etched schematics on both sides of these metal plates. And now the question is, what do we write on these metal plates? What can you write on a plate, on a 10 by 10 centimeter plate that actually describes how to read this stuff, you know? Not just how to use a laser to read it, but I don't know, what is a JPEG file, you know? Stuff like this. So things that you never think about. And that's I think, really exciting. So if you have ideas for this, also get in touch with us, because we want to put out requests for ideas towards universities early next year on this subject, because we haven't found a good solution, and I think it's an exciting subject. And then, of course, the usual stuff that we will take a small plaque, flag, token of friendship, and of course the Google and Express logo, because we get money for it. So, so much for our stuff. Now back to your stuff.
Okay, so already said it, but we really want you to think of something that that could fit into the drop container and that provides an interesting experiment on the surface of the moon. And there are like 3 rules for it. First one, it should be open. So the idea is that whatever you do, you make all the designs available for everyone to read. And the data that you retrieve will also be open for everyone to read. So if you don't want to lay open your plans of your doomsday device, you can contact us and make a proposition that we can't decline, and we will consider it seriously. We don't accept any horse heads so far, but the other thing is it should be innovative. So sending your grandma's teas to the surface of the moon is not really innovative. So we want to have something that has never been done before, that generates new data that is interesting and that the community might be actually really interested in. Also, it should be ready by 2016, which is like tomorrow in terms of space hardware. So, the idea is really that we want to create a platform for sending stuff to the surface of other planets. We want that everyone can participate in interesting experiments and doesn't have to be a university. And yeah, so it should be like CubeSat. You know, CubeSat has become a format for hobbyists to do satellites, and it's widely accepted as a format, and there's an ecosystem built around it. And so we want to create something like this. And also, it should be as easy as hacking a SCADA system, as we were shown today earlier. That should be pretty easy. So I give you a few examples of what we have in mind when we are talking about this. What you see here on the right-hand side is a sketch of what the Apollo astronauts, I think it was 17 or something, what they were observing during their mission. So when the sun was rising, they saw some twilight rays, and they had no idea where this is coming from, because if you think about Earth, you're like, oh yeah, it's coming from the clouds, but well, there is no atmosphere there, or there is an exosphere. It's a very thin atmosphere. And so they were like baffled, what could this be? And there are some good theories about it, that it could be related to some charges, that some particles are positively charged and others are negative, and so they are, they're both positively, and then so they are floating around on above the ground. And this is something that, for example, the LADI NASA mission tried to explore and collected some data about it. But on the surface itself, it would be so much more interesting to measure the size, the direction, and the speed of the particles to understand this problem, because it is a real problem for later missions. If you are on the moon and you have a mission where your camera gets dusty and you don't know why, then because there is no wind, then this should be explored, how this happens and how you can prevent it. So this is really important for future missions, and this is really just an example. Another example is you could say, okay, there are many interesting experiments that are just taking a PCB, and if you stack them together and maybe add some spring mechanism that it shoots them around, something like this, then this could be really interesting as well. So you can propose to us that you will provide us with a stack of experiments on your own. Also, we explored that you do some bombs and measure the seismic, but don't do that. No. We are using, as I said, we are using a former intercontinental mission, and if you put something that can possibly explode, then some people get very nervous about it. But we were assured that the Lucia head was removed before our mission. So one of the most pointless things that I could think of is a lunar webcam. I mean, this picture that you can see here was taken by Apollo 17 while they were on their way to the moon. So you could have a simple webcam that sits on the moon, takes a picture of Earth, and transmits it back to the same Earth that is shown in the picture.
Maybe I also can add something. You think a lunar webcam is silly? I agree with you, it's a simple thing to do, but I think it has a very good, social impact. If you can, have a website where people can actually, take their very own personal picture of the moon, or, for example, to have it in a way that you have your own image superimposed. That is something that, for example, high-altitude balloon, I don't know how to call these guys, scientists, engineers doing. So they are launching sometimes balloons where they have a mirror or a small LCD where they have images overlaid, from people, and then they take an image of the Earth in the background. And if you do something like this on the moon, I think it could be really, huge in a way to motivate people to think about space and have their very own personal image on the moon taken. And so I think a lunar webcam could, for example, be a good thing. And things that I'm personally thinking of, I really like to fiddle with stuff like these, that's which in Raspberry Pi, for example. And if you think, you love the Raspberry Pi of similar things, and you will say, I want to get this to be working on the moon, then that's also a project, and that's actually an advancement. So if you figure out some way to get this guy to survive the environment of the lunar surface, which is possible, definitely. That's something that we've learned across the last 4 years. Definitely everything is possible if you put your mind to it. So there's a whole lot of exciting things that you could do with this, and we're just giving you the opportunity.
One of the other things that that comes to my mind when we were showing you the reel of all the tests we have done, then you were seeing that that we did various tests, for example, radiation. Because you don't have an atmosphere, you're bombarded by all the radiation that is coming from mostly the sun or other particles that are floating around. And we need to know what radiation we actually need to test for. And so far, there are some measurements done by the Apollo, but those are Apollo missions, but they are not very dense. But we want a radiation monitor would be very interesting for us, because then we know what a typical moon day looks like from a radiation perspective on the surface, which can be a bit different than from the orbit, because you have some particles that are not particles, but blah blah. So anyway, it would be interesting for us. Yeah. So if you're interested in sending something from space, something from Earth to space with us in the drop container, we will publicly release kind of an FAQ for everything you need to know at the 15th of January. You can also bookmark this page, or you can visit it now, where you can find some information, or you can contact us in any meaningful way, or you can specifically send to spacehackers@ptscientist.com.
Yeah, and actually the special thing is that, as I said, it will be released on the 15th, but this is really a chance to be a little bit ahead of everybody else, because you here in the audience are the only ones who know about this opportunity, and everybody else on the internet. The point is, actually, I think it's a good time to think about what you can actually do if you can send something to the moon. And I'm personally, as I said, I'm an IT guy, so I'm more fascinated with things like protocols, for example. I don't know, if I would like to build a lunar webcam, then I was thinking about how to get the data back and how would it look transmission-wise, store and forward and stuff like this. Yeah. So there's a whole lot of awesome, for you it's just bits and electronics. So the point is, I don't think there's a whole lot of fascinating things that you can do with it. And yeah, think about this opportunity. And maybe you have already built something in the past that you would love to see on the moon or working on the moon. Yeah. It does not have to be a radiation monitor, because I wouldn't be able to build one. But if you are, then build one, definitely.
Okay. So one of the things that we want to show you is a little teaser of what we have done in the last week. Yeah, last week. Yeah, exactly. As you saw in the last picture, in the last video in the end, we were not quite happy about the quality of the images that were coming back from our camera while we were driving around. And so we wanted to remove all humans from, not from Earth, but at least from the camera view, and wanted to create really awesome pictures. And for that, we did something pretty cool, and we have a small video about that as well. 1, und los. So that is how proper rocket science looks like when you're doing it on Tenerife to get the highest possible quality of pictures. And we were very satisfied with the results. We are now so close to totally fake the mission on the lunar, on the Earth's surface. Yeah.
Yeah.
So if you have any questions for us, yeah, you can come to the microphones and ask.
Yes, thank you very much. It was a very awesome, impressive talk. I'm really, really eager to do something over there. I hope I can figure out something. And I think you guys also. So please line up at the microphone. Ask them 1,000 questions because it is really an awesome project. Over there we have the IRC guy. Some questions?
Yes, the first question is whether there will be some legislations which will be a hindrance, obstacle.
What?
Problems by law.
For what?
There are many problems by law. I mean, you mean access in the heritage side specifically?
Maybe I can answer this. Let's answer it for the heritage side. So the heritage side in this case means the Apollo landing site. And as we're going towards Apollo 17, there are some specific rules. And I actually was the one who sat in this very panel working with NASA scientists out these rules. And there's some keep out zones and stuff like simple things that make totally sense. For example, don't drive over the footsteps from Apollo astronauts. They really don't like this. So don't do it. And other stuff, for example, if you have a landing module, don't hover above the Apollo landing module. They also don't like this, you know? It's rules that make sense. That's stuff that you need to keep in mind. That's on the legal side. However, you have to understand one thing. There's nobody who can enforce these rules. So it's a delicate thing with space. You'll probably get banned from traveling to the US ever in your life again. So you really be careful. And also, of course, there's things that you definitely... I don't know, the normal human being would not be putting sensefully on the moon. I don't know, like a bottle of Coca-Cola or stuff like this, because you contaminate the surface. You know, really, it's stuff that you know that doesn't make sense. But
makes sense. Well,
it depends. If Coca-Cola gives you the money, yeah, then yes.
So there's a Planetary Protection Act which requires you to clean your spacecraft so that you're not surprised by finding humans, Earthbound life when you're going there. Later.
Thank you. Number 2, please.
Yes. I have a question about your drop containers. How to get data back from them and how much power is available from the solar arrays there?
I think that's, I don't remember the power exactly, but the data connection will be like a UART, like not high bandwidth like megabits, but probably more like up to 1 megabit, I would say, something like this. And the solar panel, I mean, you can calculate the size. It's like the size of a CubeSat. And the advantage on the moon is that you don't have the atmosphere, which sucks most of the energy out of the sunlight. So even if it's a small solar panel, it generates surprisingly much energy.
Also, sorry.
But you will find more information about all the detailed specs on the website that we just linked.
And also, of course, there maybe, but it's something that we haven't decided on, depending on the integration thing, but there's actually the chance that you can have some batteries with you. But then we need to, and that is something that always works in a dialogue, because if you say, I want to do this awesome thing on the moon and I need like this peak of power consumption and I would like to have a battery with me, that's totally fine, but somebody needs to charge the battery. In this case, it would need to be our rover, and then we need to talk. But that's something that's definitely doable. We just need the right kind of interfaces on our end, so like the power connectors.
Yeah, we want to collect all the crazy ideas that you have, and then we want to select a few ones that are not as crazy, that are actually possible, and we will provide you with an outline of what steps you need to take. For example, one of the things that we did with our rover is that we tested for vibration, which is not just because it's funny to look at, but also because it needs to survive the launch of the rocket. And obviously, you need to do those tests as well. So you need to make sure that it works with the radiation, that it works with the vibration during the launch, and that it actually works in a thermal vacuum. And the integration step of all those components is really the toughest part. As David in previous talk was outlining, there are a million things that can go wrong during integration, and so we handle those cases properly.
The good thing about the drop container payload is just that it's not mission critical. That's the big difference. So for example, if our rover fails the radiation test and we know that it will break down in 10 seconds after landing, then that's a problem, But I don't know, if we see that it's maybe or may not be, like say 80% chance that your experiment will die in 10 hours due to a radiation fault, which is likely. For example, if you shoot a Raspberry Pi up there, it can happen because it's not protected against, it's not built for this kind of things. But it's a game of statistics. It could have worked like 1 week, but it could fail in 10 minutes.
Also, failure is a very interesting data point. This is what we're always saying when something fails. Oh, that's an interesting data result.
Thank you. Number one, please.
Thanks for the talk. Perhaps a silly question about the construction of these rovers in general. I mean, more or less every rover I've seen uses these single wheels driven by a single motor, and it looks very, very fragile. Why not build it more tank-like with huge tracks and everything? Would that be too inflexible, or does the rubber not work in vacuum?
I have to add one non-technical comment. Just let me do it. Because the thing that I've noticed about the rover as it looks like today is, for me, it's definitely not fragile. It's like a tank, It's, I don't know, if it falls on your foot, then you definitely will cry, I don't know. It's really, I don't know, it does not look like something that will break easily.
But the detailed answer to your question is rather simple. One of the things that you have on the surface of the moon is called the lunar regulus, which is very, very extremely fine dust. And the Apollo astronauts, when they were jumping around and having fun on the moon, they were coming back into their ship, and they put off the glove, and they had black fingers, which was the dust that got through their suit onto their hands. And this is actually almost the answer to your question, because if you have a chain, then you have many parts that have to work mechanically, and you want to expose as little mechanical parts, moving parts as possible. Which is why it's the same reason why we have a 4-wheel configuration, basically.
Okay, makes sense. Thanks.
Thank you. From IRC, please.
Yes, there's a suggestion for a payload. So maybe what about a lightweight seismic detector to study the interior dynamics of the moon, maybe volcanic activity?
Yeah, actually, that is a very awesome idea that I've been talking about with some guys from JPL. I think like 2 years ago, they came to us and then we talked about this idea. And they actually asked us something that we've never really followed up because they had too much to do on our end, we on ours. Because the initial request was if we can put some seismic detectors on the landing legs of the lander. So that was their initial idea, but then they figured out actually it would make much more sense to have far across stretch data points. So in this case, I think maybe somebody can actually propose this, because then we have it on the radar and actually in the schedule, because maybe it makes sense to integrate, if it's a small unit, in every drop container. So you have a distributed data collection point. But this is a really good idea.
Also, this was what I was referring to with the bomb. To come back to the topic, because if you're detonating something, then it creates an effect on the surface, and if you have seismic measurement points, then you can draw conclusions from the underground. I was told by scientists that know something about it, not me.
Yeah, actually, that is the reason why, for example, it was very interesting for NASA to actually be very sure when the stuff that was orbiting the moon falls down again, because at some point it will fall down, it will crash in if you have something orbiting and if the fuel runs out. And then it's very important to understand when it hits some point to see the seismic effect of it on the sensors. And I think this, I don't know the details, but I think this is one of the data sets that ruined is not the term, but it's not very good from the Apollo missions. It's not very, they collected a lot of seismic data, but it's not really, I don't know, they're not happy with it because they think that's inconclusive or something got lost or, when you're just a human on the moon and you only have a limited time to work on the surface, then some experiments are just maybe not set up so well. So.
Yeah, thank you. Number 2, please.
Well, first of all, congratulations on winning the milestone prize. And I'd like to ask a couple of questions on your rover. How fast is your rover driving, and what is the transmission of data from the rover? I mean, what bandwidth are you using, and what is the maximum slope that you can climb with the rover, and how are you navigating it?
Okay. So we did some testing at Tenerife, and the top speed that we got was like 2 kilometers per hour, which is not something that I recommend to drive on the moon. Because the problem is that you actually have like 1.5 seconds that it takes from a signal from Earth to arrive on the moon, and then you have another 1.5 seconds that it takes until you see what you have done. And so this is why the reason why we're not driving like 50 kilometers per hour, but we are realistically more expecting to be slower. And we also tested various slopes that we can climb up, and it absolutely depends on the terrain that we are driving on. We did some high-resolution calculations. We did some high-resolution analysis of the data that we have from the Apollo 17 landing site, and we determined that it's sufficient to climb a slope of 10 degrees because this is the maximum that we can see from the data that we have from the landing site. And in our test, we were able to drive up to 10 degrees, yes. And the other one was something
How are you
like
navigating it, and what is the band you were using?
Oh yeah, the bandwidth. I will ignore the navigation. So the bandwidth we are planning to have is in the 500 meters we will have a very high bandwidth. It's very easy to do. But as we are getting more outside, for example, for reaching the 5 kilometers, we are planning to have at least 2 megabits per second, which is sufficient for some good quality video stream coming back from the rover. And navigation, well, there is no GPS there, unfortunately. But this will be done by building a map from the images. There is not much that you can do.
So is it an automatic navigation, or?
Oh no, it's remote controlled. It's a fancy remote controlled car with an optional payload for autonomous navigation. So we are working, for example, with the DLR, which have an autonomous mode, and they would be interested in having that on the rover, but it's an optional module for us. Because if we can autonomously, we can drive much faster than if we are just remote controlled.
Yeah, and the design top speed is 3.6 kilometers. That's the design one. It's really hard to test it out on Earth because you have the difference in 1/6 of gravity, So you really can't easily, it's the same thing for the slope. If you think, we did an analysis for the slopes on the moon for 10 degrees and look at it, but you can't really say if it can climb a 10-degree slope on Earth, it's the same as climbing on the moon. It's a different thing. So one thing that we did is we went to a very special lunar lab at the DLR. I think it's called Planetary Exploration Laboratory, where they have some realistic volcanic sand, which simulates the characteristics a bit of the lunar soil. And it really means that the rover, for example, can at a certain point dig itself into the ground or just to drift down from a slope side. That's also something to see if you're not just climbing a slope and just upwards, but also traveling it sidewards and see what happens if the rover just drifts down.
And those results were conclusive?
Yeah, actually, we're quite happy with them, yeah. We had no situation where the rover got totally stuck and couldn't free itself or something like this.
Yeah, this is the advantage of the four-wheel configuration that we have, because we can turn all the wheels independently. This helps us to undo the fuck-ups that we did. So also we have an active-passive suspension system. So if one of the wheels loses contact with the surface, we can lower it or higher it and recreate full contact. So this also helps to undo the last step.
Active passive suspension. So it already has some springs in it. So it already does this on its own. But you can actually adjust it with motors additionally.
Okay. Yeah, thank you. Number 4, please.
Right. Thanks for the great talk. 2 questions, 2 short questions. First one is, which kind of propulsion do you want to use for the landing module?
Yes.
Yes. Okay.
There is the right guy to ask somewhere here in the audience.
But you can ask him this question afterwards.
There he is.
No, but let's answer it later.
Yeah.
Okay.
Just ask him.
But to answer the question in one way, the thing that we're using towards the propulsion system are totally off-the-shelf components, because something that we've agreed on early on, as much as we love rocket science, we think that doing all of this and then designing rocket motors, it's too much. So that is the thing that we buy off the shelf. So, but we can have a discussion about it.
But then again, I've been told from reliable sources that just one these ball tanks costs $1 million. So
how much? 5 million?
1 million.
No, that's too much. But the point is, if you have to pay this much, then they're definitely screwing you. But
yeah, but
it's much less than this, but it's still way too expensive for any normal person. So I think that's the next big thing to tackle. And I can tell you that a whole lot of hackerspaces that I've got in touch with over the past years are actually working on designing smaller propulsion systems for more like RCS thrusters, like control thrusters and stuff like this, not the big ones, you know. And for the landing module, you need the really huge thruster, something that is very powerful to decrease the speed, you know, that you have at the point when you're in low moon orbit. So, and that's really something that's been done many times before, for example, for the ATV module that's approaching the ISS, you know, that has the same requirements as our landing module. And you can simply buy these parts and they're not costing 5 million, not even in total.
But anyway, the mission is expensive.
Yeah.
There is no way around it. You know,
that was like what I was pointing for. Where do you get the money from?
What?
Where do you get actually the money from when you just get it afterwards you've been there?
Yeah, okay. Yeah, that's actually the simple answer is from sponsors. So most of the initial money that we've had in PTS was from us themselves. And of course, it's also the same, it still applies. And of course, then from people sponsoring us. So I don't know, most of the time we're doing with companies like Symbiosis. It's always a give and take. So it's not just that we go to a company like Red Bull and say, hey guys, we want to put your sticker on there, give us 100 million or stuff like this. It's something that, I don't know, if I ask you, you would say, yeah, 100 million, I take it. But personally, for me, that's not the right way to go. You know, that's like marketing only. That's the head of NASA actually said that he would be happy to have a Mars mission funded by Coca-Cola. He just made it as an example. I don't think it's not a good thing. I think it's okay. It can work out from a marketing perspective. It's awesome. You know, it's like the Olympics or stuff like this. I think it's better if you have a cooperation partner, and that's what we have at PTS at many occasions, like SLM Solutions, the company with the 3D printed parts, for example. They're giving us money, and they're also giving us technology. So we're getting the parts, and we're getting the right kind of funding to continue our work, which is awesome. It's a good combination. What they get back from it is the right kind of learning on how to build space parts, you know, because that's a different thing, even for them. Because, I don't know, they're currently designing for like the medical industry parts or producing parts, and now they can actually produce parts that we test for space applications. And it gives them the advantage. It's not just for them, it's also for companies like NVIDIA that we're working with. So these companies can actually step up and say, hey guys, we have this technology. It's normally for the, let's say, standard open market, but there's the group out there who used our technology and put it through all the tests to work on the moon, and it worked. So it's a very good statement for these guys as well. It's like technology marketing, if you want to say it. And that's the reason for them to give us money, which I like.
Yeah, thank you. Next question from IRC, please.
Yes, what about dust on the lens of the rover? Do you have anything to avoid that? Is that a problem? Do you have anything to clean the lenses? Maybe vibrations?
We looked at all the data that we have. So there's the Lunar Source Book, is it called? It's a very, very comprehensive book about everything that we know about the moon from all missions that were sent to the moon. And as far as we can see, is that at the height of the lenses, we don't expect to have any significant amount of floating particles that could settle on the lenses. So we have right now we don't have any cleaning mechanisms on there, and we don't plan to have them.
Yeah. Yes, a problem which was mentioned could be electrostatic load.
Yeah, this electrostatic electrostatic effect is the one that keeps the particles floating, but not in a significant amount that we really have to take care of them.
One thing that we've did also as part of this year's testing was subsequent so-called lunar dust evaluations, because as I mentioned, we've tested in a planetary exploration lab which had soil similar to lunar dust, and it was really, really dusty. I think you saw it in the video, and I don't know, it was really, everything was dusty. Even the lenses were covered with dust, but they still, and that's the important thing, they still provided a good enough image quality far exceeding what was required. So that's okay, and that was after 8 hours of testing, and 3 days, 3 full days. We did the evaluation after 3 days.
Okay, thank you. Number 6, please.
Thank you for your talk. I've got 2 questions. The first one is a technical one. The solar cell is just turning on one axis. Did you consider turning on 2 axes, or why do you consider just 1 axis?
Mostly because of mechanical stability and reducing the number of movable parts. The problem is when you're launching, you have the accelerations from the launch, and to build something that is tiltable on 2 parts on 2 axes is mechanically less stable than if you just have 1 axis. The way we are driving on the moon is really we are adjusting it to the sun, and then we are driving with the adjusted way. This is why we have the camera that can tilt in any direction, and because we have the wheels that can drive in any direction, we can drive like this.
Okay, thank you. The second one is, what's Google's role in all this? Do you have to give out all your plans and schematics or something?
Yeah, but maybe I can answer this. So actually, you have to think about Google is just the so-called logo sponsor. So where does this idea of the GLXP come from? It comes actually from the so-called Ortiq prize. And what's the great thing about Ortiq? Nobody knows him. So who was Raymond Ortiq? Raymond Ortiq was a hotel millionaire who actually started his life herding sheep. You know, this guy built up a hotel. It was one time, I think in the, somewhere in the 30s or so, he was really famous for having his hotel. I think he had this Hotel Lafayette in New York. And at one point, there was a conference where people was debating at his hotel, where people were debating it's totally impossible to ever cross the Atlantic Ocean with an airplane. And because it was hosted in his hotel, he was attending this conference, and he was like, is it really impossible? And he wasn't, as I said, he was herding sheep when he started his life, and now he was a hotel millionaire. So he was really nobody who believing in the word impossible. So he said at that very day that he was awarding a very large amount of money back then to the first person to prove him wrong. That was the Ortiq prize. And you don't know Raymond Ortiq, you know him now. But who do you know? You know Charles Lindbergh. Charles Lindbergh, that's the guy who won the Ortiq prize. And he's the one who really changed it, the kind of aviation industry. 5 years after Charles Lindbergh won this Ortiq prize, we had an aviation industry where you can actually not just cross the Atlantic, but you can travel all around the world. And today you can travel to Mallorca for less than $30. So that's the point. That's what Google is doing, is giving the incentive. They're just giving the money. And the only thing that they want is, as I mentioned, this plaque, you know, there will be a plaque with their name on it. But that's the only right that they have. They have the right for us to have their logo on this thing. But that's it. We don't have to give them all schematics, details, I don't know.
So they really want to kickstart the private new space industry, as it's called. That's really their motivation.
Okay, thank you.
Okay, thank you. Number 2, please.
Hi. So thanks for the talk. I have a suggestion for the DVD specification. So I don't think you need JPEG and everything explained on the little metal plate. I think you can just say this disk contains a binary spiral of information, and the first 300 rounds are in Morse code or ASCII or UTF-8 or whatever, and then you can, and then you can explain the rest on the DVD already. So
that makes total sense. But the point is, I don't know how to make the starting point. I don't know. It's really we definitely have to talk about this, and I'm really looking forward to the suggestion because maybe it's just me, but I wouldn't know how to describe you how to read a DVD, even not after reading Wikipedia.
But I think in 50 years you can just read it with a microscope or something.
Maybe, and the point is, I don't know, it's a silly thing, but if you're talking about a future person for mankind, like in 50 years, then it might be possible to explain to them to use a laser to read out this thing. But if somebody is coming up and he has no idea what this thing is, I don't know, if he's pointing a laser at it and at the wrong point of power level, then there's a hole in there, just one more. And that's the point, and it's a total data loss. And I don't know how to figure stuff like this out, how to make sure, use a laser, use it with this power level, and this actually means power level, I don't know. It's complicated.
Yeah, maybe they don't need a laser, just a 3D scanner or something.
Yeah,
okay.
Yeah.
I get it.
Okay, thank you. Another question from IRC?
Yes, just two maybe small questions. First, you said you want to take a flag, or the flag where you may want to take it. Which flag?
More like in let's say, an open flag. So it's not something like a country flag. That's something that we would never do. Also something that we could not do because it wouldn't be reflecting PTS. Because PTS is not we're based in Germany, but we're really not a German team of rocket science. We have people from the Apollo program who actually worked on astronauts getting to the moon, part of our team from the US. We have people from Austria, of course, and we have people from France. So there's no single country flag that we could put there. It would be more like a mankind flag, or like maybe the CCC logo, if you make a good proposal.
Yes, and another small question. Would it be possible to carry liquids to the moon in the storage containers?
Sorry, to
liquids. Like
that's a very special topic. I don't know. The only scenario that I could think of is something that's an idea that I read on the internet is that people were thinking about actually bringing plants in a small unit to the moon and actually try to grow them there, like a full package with a plant and some air and stuff like this, and see how it grows on the moon. Actually, that's stuff that is really, really exciting for companies like Bayer. I know that they are doing some bacteria experiments in space a whole lot. That's thing where I could think about liquids on the moon, but as I mentioned earlier with Coca-Cola, it's, I don't know, highly debatable if it makes sense to bring a bottle of Coca-Cola to the moon, because you're polluting the surface if something goes wrong.
Anyway, but if it passes the boring answer is actually, if it passes into the array of tests, then it should be okay if it doesn't leave the containment,
Yeah.
But maybe what's the purpose then?
Yeah. One last question, please.
Yes. What science wasn't being done on the moon? What do you think that should be done science on the moon?
I can throw the question back to you. That's the question that we're putting out there. What do you think needs to be done on the moon, or what do you have in mind that you would like to do on the moon? Because there's a number of things that has been done on the moon, but it's really not that much.
Yeah, the thing is, there are so many things that are unknown about the lunar surface or the moon on itself. That there are so many experiments that you can do that would be interesting. That we really have to select from an array of experiments because all we have seen is a small area that is as big as what was it?
I don't know. The Insel of Usedom, yeah.
Usedom, yeah, something like this. It's a really small area that we have explored on the moon compared to other planets like Mars, which is fully inhabited by rovers.
And one thing to add on this, even the smallest scientific experiment that you could think of could actually change the entire course of history and the course of space exploration. That's really exciting. As I mentioned, this 3D printer, that's something that's really chilling for me, to be able to produce parts on other planets solely consisting out of the material from this planet and just energy. That's exciting, and there's other ideas like this out there, and we want you to step forward and think about it.
Yeah, thank you very much. It was a very impressive speech. I still have goosebumps all over. I hope you too. And I really like the idea to have a CCC flag on the moon. And we hacker can really make some change here, some history. So I would just give these guys a huge amount of applause because it was very awesome.